Hello, here's a short overview of new RayFire Asperity modifier. Using this modifier, you can quickly add detalization to your simple fragments. So here's my simulation of this column demolition, and as you can see, all the fragments are pretty simple. This is just irregular Voronoi fragments, and here's my fragment which I will use as reference. So here it is. So just as all fragments, it has all the interfaces selected, and this is pretty important because after you assign RayFire Asperity modifier, here it is. As you can see, it triangulates interfaces. This happens because I have here selected only checkbox on, and this triangulation rollout, and I can uncheck it. In this case, it will triangulate whole geometry. But right now I need only selected only faces, so all outer faces will not be affected anyhow. The next property is material ID, so you can triangulate only some specific faces by the material ID. And minimum area, you can use this in case you have some very small faces and you don't want them to be triangulated. You can increase this property. The most important property is this edge length here. And right now it says 10, and it means it works in relative size mode, and in relative size mode this property means 10% from original size. So the triangle edge length will be approximately equal 10% of object size. So if I will lower this value, you can see that I will start adding more triangles. Okay, like so. And basically just assigning this modifier and lowering edge length, you already see that my fragment looks pretty much more real than before. But we can add some more properties. Let's say I'll decrease it even higher. Okay, next property is this render checkbox, and it might be useful in case you don't want to have all this detalization inside the viewport. So you can check on this render, this value here, and for viewport you can set it here to, let's say, 3. So you will have pretty low resolution fragment and your viewport. But if you will render it, you'll get pretty detailed fragment here, as you can see. Also, another feature is enabling view. When it's on, it shows you all this triangulation viewport, but if you will disable it in view, you will not see any triangulation. But again, if you will, let's say, put here 0.5 value. So this is how it looks when enabling view is on, and if you will disable it, again you will see fully detailed fragment in your renderings. And another property is the smoothing. And right now, if you will see closer, you'll see that there is no any smoothing. All triangles hasn't any smoothing groups. And if I will set here auto, you'll see that now there is smoothing, but it's separated by original face. So here's you see that this face is in different smoothing groups, so they will be separated here by this edge. And the last choice is full one, and this way it simply smooth all the triangles into one smoothing group. Next property is cache faces, and this property might be increased in case you have a lot of RAM, but I suggest you to keep it as is and don't change it. I will explain about all other properties in next tutorial, and this one is just a quick overview. Next rollout I want to mention is this relax, and what it allows to do is it allows you to relax these edges. So This is how it looks without relax. Actually, I will turn off noise as well. So right now I have simply tessellated geometry, just like original simple one. So I can turn on relax. You see now that I have relaxed edges, and it's pretty simple. Works like a regular relax function. Can increase iteration and make it more roundy. Okay, I will set it 1. Next property is noise, and it also works in pretty the same way, like just like regular noise, but also it has a couple of new improvements. So the first property is scale, pretty obvious. There is no any proper setup for these properties. It depends on how you want them to look. So just play around with these properties to get the look of the fragment you want. I will just show you how it works in viewport. So this is a scale. The next property is iterations. It works only for roughness, this one. So this is roughness. You see how it affects mesh, as you can see. Okay, next one is seat. Simply change the seat. And another one is phase, in case you want to animate your noise. Next property is deflate. It allows you to deflate the whole geometry, but I suggest you to have it at 0. In some cases, when you have two fragments and they stay close to each other and you don't want them to interpenetrate with each other, you may increase deflate a little bit. Next property is keep original mesh, and it allows you to see original mesh and to see how much this noisy area goes out of original faces. So when you will increase strength, you see that okay, now here is it inside, and at this area it's outside of original mesh. So let's say you simulated original fragment, and you know you want to see where will be interpenetrations, like here you see. So you can decrease noise, or maybe deflate it a little bit to prevent this. Or maybe you even will change phase completely to prevent this, or change seat, whatever. You have several ways to fix this. Okay, it's off. Let me increase strength. As you see, some parts of the geometry is inside of original, beneath original faces, and some areas is outside. So here we can use this normal spinner, and in this case all the vertices will go straight in one direction, and as you can see right now my Z strength is positive. So here's it's at 0. When I increase it, you see even though my keep original mesh is on, all the new vertices goes out of the original surface. And if I will start decreasing the strength and go to the negative value, it will go to the only in negative way. So this is just another way to control your noise, so you can get some bumpy fragments or some fragments with a lot of concavities. Also, you can see that now I have some artifacts here because my strength is too big, and there are some intersections. I can go to relax, increase iteration, and smooth these edges out. So now I don't have any problems. Now we'll set normal to 0, and now what I want to do is I will increase my strength just too high on purpose. Of course it's not what you're going to use, but I am doing this to show you this problem you may have. Here you can see there's an intersection area goes intersecting with original area, original surface. And of course this is not appropriate. And here when you can use this vertex selection rollout, as you can see there's fall-off property. It also works in relative fall-off and relative mode and absolute mode. And again, right now 10% means it's affects only 10% of so you can go to this vertex selection mode. Now you can see this smooth soft selection, and as you can see, the closer this vertex to the original surface, the less they affected by noise strength. And this is where you can define how big this area will be. So increasing it, I am smoothing out all this area. So here's my problem part, and I can increase it and until it will be gone. It will gone. So now it looks okay. And using this property again, you can use in relative mode and you can use it in absolute mode. Then there's a couple more properties like easing, like it will be none, just a linear fall off, and you can make it in, out, or make it combination from in and out. Okay. Now I want to show you. Also, I want to mention that there's a gizmo for the noise, and it's you can move it. You can let me decrease strength to something more appropriate. You can move it, you can rotate it, do whatever you want, just a regular helper. You can even scale it to get some interesting look of your fragments, something like this. Maybe decrease edge length. So you see now it has some pattern, interesting pattern. Okay, now I want to show you how to use this modifier when you have a lot of objects. Okay, to better show you, I will use two boxes. Just it'll be easier to show. So here I have two boxes, and let me animate them. So I will make a copy, and first I will assign to this two boxes. Check off selected only, increase, decrease edge length, maybe 1. And now I will increase strength. So you see, whenever I increase the strength or even go to the gizmo and move this gizmo, you see, let me increase relax. So here's the H. Actually, I will change color some other. So as you can see, they fit each other. If I change noise strength or noise scale, no matter what, if I will move their gizmo, since this modifiers are instances, they affect in the same way. And you see they fit each other. The noise is the same. But if I will assign to the same two objects, when they are not close to each other, when I will move them closer to each other, you see they do not fit each other because their gizmo is different. This is a gizmo of one object and this is a gizmo of another one. They do not fit each other. When you assign when you assign Asperity to two objects which are close to each other, the gizmo fit each other, so they have the same noise scale. Uh, when you assign them when are they not connected, you get interpolations when you move them close to each other. See? So here's a simple rule. If you have some geometry which already have some simulation, and you don't want to have all the interpretations, you should assign this Asperity modifier only when this object's fragments are looks like they're not demolished. So assign them not when they are already on the ground, but while they are just one object. Looks like one solid object. Then you can play simulation and start playing with properties. Sometimes it might take for a while, like right now I have several hundreds of fragments and my edge length is pretty low, so okay, looks like it's done. And now you can see that my fragments, which were very simple before, pretty flat, looks much more real now. So I can disable it in view. This is how it looks before, and then render it. And this is how they looks after. Okay, I think that's enough. There will be more tutorials later. That was just a quick overview, and thank you for watching.